Welcome to Signals and Systems subject classes. So this is the third chapter, that is continuous time Fourier series. So this is the third class or part 3. Previously we have discussed about Fourier series representation and the derivation of the Fourier series coefficient. And we have done some two problems regarding the Fourier series representation and coefficient. Now in this class we are going to discuss properties of the continuous time Fourier series. Here we have 15 properties. So one by one we have to discuss these properties of the Fourier series. So again I want to write Fourier series representation and Fourier series coefficient formula that see this is a Fourier series, it's related to the continuous time. So in x of t, so this x of t, so it's a periodic signal. So it can be written in terms of the complex exponential, is it? So any periodic signal can be written in terms of the complex exponential. That is nothing but Fourier series representation. So sigma, so ak into, this is the coefficient of the complex exponential, e power j into k omega naught into t. So k varies from the minus infinity to plus infinity. Is it? So this is Fourier series representation. So it's Fourier series coefficient. So that ak equal to, so time period. So we know that the Fourier series applicable for the period signal, is it? So capital T is the time period of the x of t. So this is a x of t is a period signal, then just do the integration within the one time period. So x of t into e power minus jk omega naught t into dt. Is it? So this is Fourier series coefficient. So this x of t is a periodic signal. We are converting to the time domain to the frequency domain. Here ak is it is in the frequency domain, is it? So whenever you apply the Fourier series to the x of t, it becomes ak, is it? Is it? Now this x of t is a periodic signal. So this is periodic. But ak is not periodic, it is aperiodic. So in examination point of view, you should remember these are very important. So this is aperiodic. So this x of t, it is a continuous time, is it? We are taking the continuous time. We are already here. I have written this is CT continuous time Fourier series, is it? So x of t, we know that. So x of t is a continuous time. Continuous time. Coming to the ak, already we know that k so ak we have drawn ak versus k. K is an integer. So automatically, so ak is nothing but is a discrete, is it? It is a discrete format. So these are very important, is it? So x of t is a periodic signal, ak is a aperiodic signal. This x of t is a continuous time, ak is a discrete time. So in CT or in DT Fourier series, ak always discrete time, is it? So properties, we are going to discuss properties. These properties, the first one, linearity. So to verify the linearity, whether means this Fourier series whether it follows the linearity or not. So to checking the linearity, the Fourier series must be follow the superposition. It must be satisfy the superposition. It is nothing but scaling property and additivity property, is it? Once it satisfies the scaling and additivity, then we can say this Fourier series it can follow the linearity, is it? For that, here I am taking two signals, is it? Two signals. One signal Fourier series coefficient. So one signal x of t is one of the signal corresponding its Fourier series coefficient I am taking, that is ak. So ak is a Fourier series coefficient for the x of t, is it? Next, another signal. Why? Because to verify the linearity, we should take the two signals, is it? So the second signal I am taking, that is y of t. So y of t, the corresponding Fourier series coefficient, I am assuming that is bk, is it? bk is a Fourier series coefficient for the y of t. Now, if you add these two with coefficient, with any multiplication, the same thing if you get in the frequency domain, then we can say that this Fourier series follows the linearity, is it? For example, now I am taking the x of t with the one multiplication multiplier, that is, for example, a into x of t, is it? Plus b into y of t. Now I am applying this Fourier series. So if I get the in the frequency domain like this, so for the a is a constant and x of t Fourier coefficient is ak. Then so b constant and its Fourier series coefficient y of t Fourier series coefficient that equal to bk, is it? So this Fourier series it follows the linearity, is it? The second one is time shifting property. Time shifting property. So in this time shifting property, again, for example, I am taking the x of t. So x of t, its Fourier series coefficient equal to ak, is it? Now I am applying this time shifting transformation. See, so x of t minus t naught. For this, what is the Fourier series coefficient? Is it? For example, I am assuming this Fourier series coefficient equal to bk. Is it? Then, so bk must be, see, this x of t minus t naught is a transformation is applied to the x of t. So this bk must be in terms of the ak. Is it? That we should find out. Is it? For that, I'm taking the Fourier series representation. So x of t that equal to sigma ak into e power jk omega naught t, is it? So k from minus infinity to the plus infinity, is it? So now we are going to find the Fourier series coefficient for the x of t minus t. So now I'm replacing the t by the t minus t naught, is it? We are replacing the t minus t naught in place of the t, is it? So just replace the t naught minus t naught in place of the t. So in the equation also, so k from minus infinity to plus infinity, so ak into e power jk omega naught into, so just substitute t minus t naught in place of the t, is it? So t minus t naught, so here t naught is the constant, is it? It will, so it is any value, is it? For this expansion, so k minus infinity to plus infinity, ak e power jk omega naught t into e power minus jk omega naught into t naught, is it? So k equal to minus infinity to plus infinity, so ak into e power, I am writing this is ak multiplier, so minus jk omega naught into t naught into, so this is Fourier's coefficient, is it? Into e power jk omega naught into t, is it? So this is the Fourier series representation for the x of t minus t naught. From this equation we see, so this is a Fourier series coefficient, so this is the ak is a Fourier series coefficient for the x of t, is it? See e power jk omega naught t, here e power jk omega naught t, so this overall this is a function of the k, is it? This is the overall function of the k, is it? So this function of k, it is regarding to the, it is corresponding to the x of t minus t naught, is it? So you can write, so the bk equal to, so the bk equal to what? That is ak into e power minus jk omega naught into t. So this is the time shifting property. Same this is a time delay for the for the advanced, directly we can write this x of, so t plus t naught, so this is right note, is it? So in note, so its Fourier series coefficient in terms of the ak, is it? So ak, so here for the minus we are getting the minus, so for here you should take the positive, is it? So jk omega naught into t naught. So this is the time shifting. Next we go for the next frequency shifting. The third one is frequency shifting. So this frequency shifting, again I am taking continuous time signal, that is x of t. So this x of t, it is corresponding Fourier coefficient is ak, is it? Now we are applying the shifting in the frequency, is it? Shifting in, so shifting, so ak, so k is a variable, so k naught, or you can take m or k naught, anything, so k naught is a constant, is it? K naught is a constant. Then what is the signal corresponding this ak minus k naught, is it? We need to find the time domain signal corresponding this shifting in the frequency, is it? So we will prove it. So first of all, I am going to take the, we are finding the signal in time domain, is it? So here I am taking Then you can take Fourier series representation formula or coefficient formula. Anything you can take. Is it? So I'm taking the Fourier series coefficient formula. So AK equal to 1 by T integral 0 to T x of T into e power minus jk omega naught T into dt. Is it? So what we are doing? So what we have to do? We have to find a k minus k naught signal. Is it? So just replace a k minus k naught, that equal to 1 by T integral 0 to T. So x of T, so e power minus j. So just replace the k minus k naught in place of the k. So k minus k naught omega naught T into dt. So that equal to 1 by T integral 0 to T. So x of T into e power minus j k omega naught T into e power, so minus into minus plus, so j k naught omega naught into T into dt. So 1 by T integral, so 0 to T x of T is it is a signal in the time domain. X of T into e power jk so k naught omega naught into T into e power minus jk omega naught into T into dt. So this is formula for the a k minus k naught. So this is x of t. It is a signal in the time domain. So e power j k naught is a constant. Is it? So k is a variable, k naught is a constant, omega naught and t. So this overall is a function of the t. Is it? Is a function of the t. Is it? Then here we understand that. So this is the Fourier coefficient for this signal. Is it? So Fourier series coefficient a k minus k naught, the corresponding signal is x of t into e power j k naught omega naught t. Is it? That here we should write. So the corresponding signal in the time domain, that equal to, so x of t into e power j k naught not k naught omega naught into t. So this overall it is a signal in time domain. Is it? Time domain. Is it? So it is not function of the k. Next property, time reversal. So time reversal. So the time reversal, similarly, I am taking the continuous time signal, continuous time periodic signal x of t. Its Fourier series coefficient. So this x of t ak, it's called Fourier series pairs. Okay, Fourier series pair. So Fourier series, is it? So now I am applying time reversal. So transformation of the signal, is it? So x of minus t. For this change in the time domain, what is the change in the frequency coefficient? Same here, just apply. So For this, again I am taking the Fourier series representation. So x of t equal to, so sigma ak into e power jk omega naught into t, is it? So k equal to minus infinity to plus infinity. Now we are going to finding the Fourier coefficient for the x of minus t, is it? So just replace minus t in place of the t. So in right side, we should do that. We should apply that one. So minus into plus infinity, so this ak, there is no t here. So e power jk omega naught. So here t is here, is it? So replace the minus t in place of the t. So minus t, is it? So here I am changing k equal to minus infinity, so plus infinity. So ak equal to e power j into, now here I'm taking the minus to the, I'm applying to the this k, is it? So I'm writing here minus k, is it? Omega naught into t x of, so to write to find the Fourier coefficient, that the exponential must be like this. What is that? E power, it must be e power j something something into omega naught into t, is it? Now here I'm taking, I'm changing this sign, is it? Otherwise, you can take here. I'm assuming minus k equal to something variable L, is it? So there is no change in the limits, is it? So minus infinity to plus infinity. So it k equal to minus L, is it? Minus L. So e power jl omega naught into t, is it? So it is similar to the sigma k equal to minus into a minus, so this is a, so x of minus t, is it? So e power j something k omega naught into t or L, is it? So this a of minus L is, it is a Fourier series coefficient for the x of minus t, is it? So here variable is L, so we can also take the variable as a k, is it? We can write again. I'm going to change, just I'm changing the only name only. So k equal to minus infinity to plus infinity. So a minus k e power j k omega naught into t. It is interchange. We can write in any letter. Is it just that is one English letter only? Is it L? We can take any letter. Okay. Where in the on our Fourier series, k is the main variable. So that's why I'm converting the L to the k. Is it? Again, here also we can take directly here. If you take the k here, you should replace the minus k. That is concept, is it? So here we understood that. So x of minus t, its Fourier series coefficient. So its Fourier series coefficient that equal to a minus k. Is it? So a minus k. Now next fifth one. Time scaling. So time scaling property. Yeah, now basic signal, that is any signal that continuous time period signal, that is x of t. So Fourier series coefficient is ak. So what is the Fourier series coefficient for the scaling of the x of t? So that's I'm scaling. I'm taking that scaling like x of alpha t. Again, here already here is taken as a Fourier coefficient. So that is here I'm taking alpha. Is it? So its corresponding Fourier coefficient is what? For this explanation, again I'm taking the Fourier series representation. So that is, so x of t, we know that the Fourier series representation. So any periodic signal, you should remember, any periodic signal, it can be written in terms of the complex exponential signal. That is a Fourier series representation. Nothing is there. So k equal to minus infinity, infinite, k from minus infinity to infinite, ak into e power jk omega naught into t. Again, apply the scaling. So just replace the alpha t in place of the t. So x of alpha t, so that equal to k equal to minus infinity to plus infinity. So this is a constant, is it? This is a constant. So you should remember this angular frequency omega naught equal to 2 pi t, is it? So these two are constant. So ak e power jk 2 pi by t alpha into t, is it? Now here writing k from minus into plus infinity ak into e power jk. Here I'm writing, so this is now I'm applying this alpha to the t. So we can write t by alpha into t. Is it? So time period is divided by alpha. Is it? That is new time period. This is new time period t dash that equal to t by alpha. Is it? So new frequency is omega naught dash. Is it? So from this concept, we understood that ak e power jk omega naught into t something. Is it? So there is no change in the Fourier series coefficient. Same Fourier series coefficient we are getting. So x of t Fourier series coefficient ak, x of alpha t for the time scaling of the x of t Fourier series coefficient also same. Only time period will be changed, is it? So there is same ak. So in this case only, we are getting the same for first quotient, even though changing in the time period, time signal changing in the time domain signal, same AK we are getting. Next, convolution, periodic convolution. Periodic convolution. So in the periodic convolution, again, for the convolution, we should take the two signals, is it? So x of t, Fourier series coefficient, Fourier series coefficient, here also we should write this is Fourier series, ak y of t is Fourier series coefficient bk, is it? Now convolution, so in convolution in the time domain, so x of t convolution y of t, So this is equal to, you can write x of tau y of t minus tau into d tau. So these are the time periodic signals. So we should we do the integration within the one time period, is it? So this equal to, so convolution in the time period, but in the frequency domain there is a multiplication, is it? So ak into bk, that's enough. Ak into bk, but we should take, so here the integration in the formula, default in the formula we have the 1 by t, is it? So this here we will get the extra t multiplication, is it? So this is about periodic convolution, simple thing. So you should remember this is very important concept in any conversation, in any Laplace or Z transform or Fourier transform in anywhere. If you apply the convolution in time domain, the corresponding in the frequency domain, that is the multiplication, is it? Next one, the seventh one is now multiplication. So periodic convolution in time domain, multiplication in the time domain, multiplication. So multiplication in the time domain, the corresponding in frequency domain, that is the convolution, is it? So x of t, its Fourier series coefficient is ak. So y of t, its Fourier series coefficient is bk, is it? So the multiplication is, so x of t into y of t, x of t, y of t. So that Fourier series, so there is a ak bk convolution, is it? Convolution, here I'm directly I'm writing the convolution, I'm applying convolution. First change the variable, so al and k minus l. So it is not periodic, ak bk are not periodic, it is a periodic signal. So you should take the limits from the minus infinity to plus infinity. If it is periodic, just you take the limits only periodic, is it? So this is about the multiplication property. The remaining properties we will discuss the next class. Thank you.